climate change is a growing threat to our agriculture industry. It's causing droughts and the depletion of our water resources, putting food production at risk and causing massive water scarcity. It's leading our scientists to go in search of new water sources. Among them is marieh, a scientist from NYU Abu Dhabi. Gathering her research tools, she's heading into the desert. She is here to study a plant that thrives in this arid climate.
I'm here to study these specific desert plants, or what we call them as halophytes.
Marieh is set to see how these plants have managed and adapted to survive in one of the world's harshest climates.
These plants can tolerate really high concentrations of salts. They absorb that salty water from the soil. They have the capabilities of filtering that salt from the salty water as it goes inside the plant, and then concentrate that salt and excrete it from its system using specific salt glands. So it gets rid of that salt and it takes the pure water for itself.
To the naked eye, they don't look like much. But under a microscope camera, Marieh discovered a natural wonder. Entire branches covered in thousands of salt crystals.
So these salt crystals are very hygroscopic, which means that they like to attract water from the air and at very low humidity and condense that on the surface of the branch. And this is very important for the research that is being done in to combat water scarcity. So the idea is we have this environmental friendly material that is excreted by these plants, these salt crystals that love water, and they can capture water from the air.
Back in NYU Abu Dhabi's Smart Materials Lab, Marieh has been conducting further research and analyzing her findings.
Can I take a look? This is so beautiful. I'm just seeing little specks of salt crystals. If you just look at it with the naked eye, I mean, it's really not an exciting specimen. Zoomed in, everything changes.
Marieh's findings have just been published in a scientific journal. She has further research to do, but is confident that after finding a desert plant that can harness water from the air, it will have positive implications for our water security.
Right now, we've discovered this natural system.
How would you put this into practical use? How would you deploy that in the real world?
We can easily make them in the lab. We could make small devices using these salts to attract and capture water from the air. If we want to take a look at the bigger picture, if we want to tackle, for example, water crisis, we need a lot of water, right? So what we think is that these salts might play a role in cloud seeding. And the idea in cloud seeding is very simple. They spray them in the air, in the clouds. Those salts will capture some water from the air. The droplets will grow larger in size, and then they will drop to the ground and in the form of rain and precipitation. What makes these plants so special is that they're capable of attracting and condensing water at low humidity levels. You don't really need a lot of water in the air to condense that. Even if you have very few water droplets in the air, these will be collected by the special salt.